Welcome to class 7 mathematics classes. Today we'll discuss about fundamental geometrical concepts. Fundamental means basics, which is very important to understand. So in geometry, basic terms that we should understand are the words which describes some figure. I hope you all are familiar with these terms, but clear concept you may not have. Let us discuss in detail these terms today. At first, point will describe. Okay, so here you can see these dots. We call in common language these all as dots. Okay, but in geometry we call them as point. Okay, so a point is a mark of an exact location. Okay, when we are making a mark here, that means we are making a point here. Okay, and exactly here only we have done it, so it represents exact location. Okay, these all are points. So many points we can make on this paper, isn't it? So you can see here this point has no dimension. No dimension means it has no length, no breadth, and no thickness, and it does not occupies any space. In fact, it occupies space, but it is negligible. This space is occupied by this point, but will not consider that it has occupied any space here. Why? Because it is negligible. Okay, it is negligible. A dot, a point can be represented in this form also. This form also, you can see this. Yes or no? I'll show you in this one. So here, look at this. This is a dot. So it is a point. This is a dot. This is a point. Now, the naming of the point, how to name a point, okay, in geometry. So a point is denoted by a capital letter. Any point, we name it by a capital letter. Suppose X, Y, Z, okay, by capital letter. More points you can make here and name it as A, B, C. I hope you have now some clear concept about point. Okay, so in this manner we should remember a point in geometry. Next is a line segment. Okay, let me draw a line at first here using this ruler. So this is a line here. So let us represent endpoints by some letters A and B. This line is made up of several points, okay, moving towards in one direction. Okay, so this is the starting point and this is the end point. So a line segment is having starting point and end point. So that means it has 2 points, starting and end. So we can say it has 2 end points, and the length we can measure from here to here using a scale. We can measure the length of this line. Yes or no? The distance from A and B is called the length of the line AB. We can represent a line segment by writing A, B, the endpoints, and the bar above these letters. Okay, so this line is represented by this in geometry. AB bar is a line segment. Line segment has length, fixed length. Okay, and when 2 points are given, like here one and here one. By only one line we can join these points. Line here means straight line, not a curved line. Okay, so by only one line we can join these 2 points, and any no more than this we cannot join. Okay, so only one line is there which can join these 2 points, and we can measure the length of this line segment. We can say that two line segments are equal if they have same length. Another line I can make here from here to here. Okay, suppose this one is 3 centimeter and this one is also 3 centimeter, then we can say these two lines are equal. Okay, now a ray, a line segment extended endlessly in one direction is called a ray. Like this is a line segment, this is a line segment. Okay, and the name is AB, and it is extended endlessly towards B direction. Okay, and the head of this is represented by one arrow or marked by an arrow. Okay, so a ray is represented as AB, and above this AB one arrow. Okay, so this represents ray. From a point O we can draw infinite numbers of arrows. Okay, like 1, 2, from the middle of this also 3, 4, 5, and so on. So many arrows from a point we can draw. Suppose this is OA, this is B, this is C, this is D, this is E. So here how many rays? OA, OB, OC, OD, OE. Okay, OA, OB, OC, OD, OE. From a point many rays can be there. Okay, a ray has only one end point, that is the initial point, starting point of that ray. Okay, this side the end point we don't know where it ends, so that is why a ray has only one end point, and it does not have any definite length. Okay, like in line segment we have definite length, but in case of ray it does not have definite length because we don't know where it ends, where this ray ends. Okay, we have only one initial point, that is end point, and suppose two rays are there. This is BA. Okay, BA, initial point is B, and this side the ray is moving towards A. So BA, this is the ray. Now AB, ray AB is not equal to BA. Okay, do remember as the direction of the rays are different. Okay, it is moving to this direction and it is moving to opposite direction of AB. So that is why AB and BA are not same. Okay, now line. Okay, a line segment extended endlessly in both the direction is called a line. Okay, like this line is extended both the direction. Okay, this direction also it is moving and this direction also it is moving. So it is not possible to draw a line in this paper because this is extending this side and this is extending this side. So we represent a line by AB and above this arrows at the ends. Okay, so line is represented by this, and a line has no endpoints. Okay, and it has no definite length also. We cannot measure the length of the line as it is extending both the sides, so we cannot exactly say that from here to here. Okay, so that is why we cannot measure the length of the line, and it has no endpoints. Starting point also we don't know, and where it is ending, that is also we don't know. So that means we don't have endpoints for a line. Okay, line sometimes represented by small letters also, like L, M, N. This line can be named as L. Okay, line L means this line, or we can represent in this manner also. So there are two ways to name a line. Now next is plane. A plane, like a tabletop. Okay, you have seen table, and the top of the table is the plane. You have seen blackboard, the surface of the blackboard, the face of the blackboard is a plane. Okay, and walls you have seen, the face of the walls are the planes. Okay, a plane is having two dimensions, length and breadth. Suppose this paper, it has length and breadth. Okay, but no height or thickness. It doesn't have thickness. So a plane is a figure, okay, which have length and breadth. And any figure that we draw on the plane are also plane figures. Okay, like triangle, rectangle, circle. So these are plane figures. Suppose here I am drawing one plane figure like a rectangle. Suppose this is a rectangle. It is a rectangle. Okay, so it has length, and it has breadth. Okay, but no height or thickness. And a circle, this is also a plane figure. It has no thickness. Okay, triangle, this is also a plane figure. We can draw this figure on this plane. Okay, on this plane means on this paper. So paper is also a plane. Okay, so in this manner we should understand plane. Now let's see collinear points. A line, okay, a line segment or a line. Suppose this is a line and this point of the line is A and this point of the line is B and this point of the line is C. Okay, there can be many points, like this point is D. Okay, so collinear points are the points which lie on the same line. Okay, these two, suppose this is the starting and this is the end line segment we have taken out from this line, and between so many points are there. Okay, they are called as collinear points. So three or more points, one, two, three or more points lying on a line are called as collinear points. Okay, so here in this figure, point A, B, C lie on the line L. Suppose the name of the line is L, and they are collinear. But the points P, Q, R not collinear because they are not lying on the line. Okay, they are on the same plane, but they are not on the line L. So that is why they are not collinear points. A, B, C, D are collinear points. They are lying on the same line L. Okay, try to understand. Now let's talk about intersecting lines. Intersecting lines means two lines. Two lines, suppose one line and another line. This is line L and this is line M. They have a common point. Line L and line M are having one common point. That is, suppose this point named as O. O is the common point of line L and M. In such case, line L and M are called as intersecting lines. Okay, in this case, O is the intersecting point of L and M. Okay, there will be only one common point. Okay, there will be only one common point. Like here, one more I am making. Suppose this is N and this is M and this is suppose Z. Okay, it can have like this also. These two lines are suppose P and Q and the common point is R. Okay, so these are intersecting lines. Okay, now concurrent lines. Now in the same manner of intersecting, if more than two lines have one common point, okay, more than two lines, if they have one common point L, M, N, so there are three lines L, M, N, and they have one common point O. Okay, so this is the intersecting point of three lines. Okay, and this case we'll call these lines as concurrent lines. So three or more, it can be more than three, but at least three we'll consider. If there are two lines having one common point, then we call them as intersecting lines, and if it is three and more than three having one common point of intersection, then we call them as concurrent lines. Here L, M, N, P or Q, let me write Q. Okay, line L, M, and Q are concurrent lines as they have one common point, that is O. Okay, now let us discuss about parallel lines. For parallel lines, let us take two lines. Okay, one line and this is a line and another line here. So this is L and this is M, line L and line M. These two lines are parallel. When they are parallel, when the distance between them at every point is same. Okay, suppose the distance between them is 5 centimeter. And if you measure from here to here, you will get 5 centimeter for parallel lines. If you measure from here to here, you should get 5 centimeter for parallel lines. From here to here also 5 centimeter. So each and every point just opposite to one another, the distance between them is 5 centimeter in this case. That means if the distance between the points of two lines, okay, is equal at every marks, okay, or at every opposite points, then they are called as parallel lines. And parallel lines, how much you will extend, they will never going to meet on the same plane. Okay, we're talking about on the same plane. So two parallel lines can be represented as L parallel to M. In this manner we represent L parallel to M, means in this way they are, okay, they are never going to intersect on the same plane. Okay, so there are two conditions of two lines on a plane. They may be parallel to each other or they may be intersecting. Okay, there are two conditions: they may be parallel or they may be intersecting to each other. Only these two conditions are there on the same plane for two lines. Okay, they can be parallel to each other or they can be intersecting to each other. So we have done some fundamental geometrical concepts. We need to remember these all for doing geometrical work. Okay, thank you very much.